Welcome back to Rev Endurance Sports, and today I have Charles with me. We're going to do an episode of bike profiles, but we're also going to do some tech talk on metals and carbon fiber and such. So Charles, just for an introduction, you're a composites engineer. What do you do?
So I'm an engineer at General Atomics ASI.
Yep.
And part of my job includes designing and evaluating composite components.
Composite components. Yep. What, like wing structures or what?
I can't tell you, it's
Oh,
classified.
okay. All right. No, that's perfect. That's perfect. And little factoid, I used to work at the company he works at back in like 97. So, all right. So with that background that you do composites,
Yep.
Let's talk about why, or let's talk about this bike, because this is a magnesium frame, right?
Yep, that's correct. This is an Alite super magnesium frame.
Yep.
It is.
Did you say light?
Alite is the manufacturer of the alloy.
Oh, okay. So they actually.
Yeah, they make the alloy for the tubes.
Okay.
And then.
And where are they from?
The Alite is from Ohio.
Ohio.
The manufacturing of this frame from the metal they ship out is done in Taiwan.
Okay.
These are hydroformed tubes.
So they buy the tubes from Taiwan, but they do the welding.
They make the tubes in Taiwan out of metal sourced from Ohio.
Oh, okay,
Yep.
okay.
And hydroform them
Yeah,
and weld them,
yeah.
and then the entire.
Could you explain hydroforming?
Certainly. Imagine inflating a bicycle tire and tube until they permanently deform inside a shell mold that will not itself deform.
Right.
And so you can start with something that's a tube's shape.
Yeah.
And you can easily make it an oval. You can less easily, but it's possible, make it
Squoval, like
conform
Sorello used to. Yeah.
conform to a square.
Yeah, yeah.
And some other shapes are not done by that process because they'd be impossible, such as the rear dropouts, which are just milled and then welded on.
Yep, yep, yep.
And yeah, the hydroforming process can reach almost any shape that has a closed section. You can have variable cross section along it, such as this bottom tube. And yeah.
Now I know they've done hydroforming with aluminum.
Correct.
So is there only a few metals that you would want to do this with for bicycle frames, like just aluminum and mag?
You can hydroform any malleable material. So you can, it's likely that any metal that you would make a bicycle frame out of, you can hydroform well. And very good two-stroke dirt bike parts are hydroformed, two-stroke dirt bike expansion chambers are hydroformed from steel.
So an expansion chamber coming out of the the engine going
Yep.
into the, like the header.
Correct.
Okay, like the header and then the muffler pipes.
Yep.
Yeah.
And so they do that hydroforming step, and then it's welded.
Yep.
And that produces the frame.
Yeah.
And it's one of the lightest metallic frames you can buy.
Interesting. Okay. Okay.
And then I got it. And I got it with SRAM Force because I don't like cables all over the place.
Right.
So it's all shift by radio.
Yeah.
It has disc brakes, and George just did the installation of these Continental GP 5000 tubes.
Yeah, we just did this tubeless install on these 30s. You came in riding 25s, and so I asked, wow, that's a big jump from 25 to 30. You're an engineer, so tell me your perspective of what you've been researching and analyzing, going from, like, let's say a 25 to a 30.
It's likely that the only really good research is done by the tire manufacturers themselves, who, as far as I can tell in the automotive industry, are 10, 15 years ahead of the OEMs anyway for the rest of the car.
Yeah.
But they tend to only move in one direction. There are very few false starts in tires. If you notice, all the trends in tires tend to continue into their natural conclusion.
Yeah.
And road bike tires have been getting wider because the people on the wider tires have been beating the people with the narrower tires in races. So
Yeah.
there's really not much to say on that.
Yeah.
The 30 millimeter is just the widest GP 5000 Continental currently makes. I've got enough clearance for maybe a 32 on here later if they start making them. Maybe a 35, but I'm crossing my fingers on that one. So
I do appreciate that you got this crank set from me as well.
Yep.
So I appreciate your repeat business more than you know, but yeah. So you've got 165, right? Is that what
Correct,
we ended up getting?
165.
165.
I have these big, wide, short legs, and so they'll turn over. They make lots of power. Turns over just fine at 110 RPM. It's just that if I'm out here cranking away, I'm wobbling all over the place. So. And
just to give some perspective, how tall are you? Because you look about my height.
I'm 5'8".
Yeah. All right. So you're 5'8", shorter legs, and you went with a 165 crank arm, and I can see that the saddle is quite low as well inside the frame. Is this a medium? What do they call these?
Yep, they just call it a medium.
They call it a medium. Okay. And all right. So you've got some ideas about why your next bike should be a metal bike.
Yep.
Why don't you share some of that information with our viewers?
So the first thing you'll see in the marketing materials from a carbon fiber bike is, of course, the exceptionally low weights that can be achieved for the frames in carbon. And the next thing you'll see is this terrific elastic modulus of 200 gigapascals. So you'd have to have on a 1 millimeter by 1 millimeter carbon wire a weight of 50 tons to double it in length.
Yeah.
And you go and compare that, and that's almost the same elastic modulus as steel.
Oh.
For a material that weighs 1/5 as much. And then, so that makes all the metallic materials look sick at first, because, well, you take aluminum, that's only 70 gigapascals, and it's a third of the density of steel, and that's a third of the modulus. So you say, okay, well, those two are in proportion. And that goes for the rest of the structural metals. Aluminum, mag, ti, steel, just form a series.
Yeah.
More elastic modulus, more density. And so you think, great, carbon fiber completely breaks this. Go get a carbon bike. All right, you can't make something out of straight carbon fiber.
Yeah.
You can. It's a cable.
Yeah.
It doesn't. To make it form a permanent shape, you mix it with resin.
Right.
And that drops the elastic modulus, because the resin has no elastic modulus, by about 40%. I know in some aerospace applications we make stuff that's only 25% resin, but most of the time you're talking 40%
well, let's just
resin.
Say, for bikes.
All right, so you're down from 211 to 120.
Okay.
All right, that's stiff in exactly one direction.
That's true. Yep.
And if you apply tension and compression to it, yeah, that's great. You can have a chain stay or a seat stay that are exceptionally stiff in the direction that the primary loads are in. Great. Now, what happens when you ride a bicycle? That's right, you go around corners.
Okay.
Well, you go around a corner, and yes, it's a coordinated turn, so most of the weight is put in this way, but any lateral load, if you're not in a perfectly coordinated turn, goes up this way relative to this, and you now have your main triangle in bending. And so now you've got it in bending, so now one side's in compression, one side's in tension, one side's in shear, and you only have one tube to react both sides of it.
Yeah.
So now you're dealing with a substantial fraction of your fibers no longer can run along the axis of this tube. They have to run circumferentially around it. And
do they lay it up that way?
Absolutely.
Okay.
To get a rideable carbon bike, you have to do that.
Okay. All right.
And by the time you get a laminate for the front section of a frame, well, you're starting to stare at, you start at 210.
Yeah.
You put some resin at you're down at 120.
120, 40%.
And then you get another cut down, let's say, of only having the fibers in tension taking maybe 40, of the laminate, and the rest of it is at 45s and fully circumferential, and all of a sudden you're staring at a laminate that has an elastic modulus that's down in the 40s or 50s. You realize, wait a second, so it's got a density of 1.8 or so, and it's got an elastic modulus of 45 or so, and it's fragile. And wait a second, what's the elastic modulus of magnesium again? Oh, right.
What is it?
It's about 50.
Yeah.
It's 45, it's 45, 50. I forgot the
really
exact.
close to
I can
it.
tell you what the exact values are for aluminum, because I have that at the top of my head. It's
Yeah.
2.7 grams per cubic centimeter in 70. So magnesium's 1.8. Yeah, it's 45 or so for mag.
So you're right there again.
So you've got the same stiffness to weight, and you got something that you have to take special care to never allow to get dinged, dented, or scratched or scraped, or, well, I don't know, treated like a bicycle.
Yeah.
And so, yes, you get...
Try not to crash.
Try not to, well, I mean, don't crash any bike, right?
No, for sure.
You can hurt yourself, and you can damage a bike made of steel, aluminum, mag, tie, just as badly as you can make damage one out of carbon fiber.
Yeah.
But, you know, there you are. You've got, you can reach the same properties, and you can reach pretty much the same frame weight as a carbon bike in either aluminum or magnesium.
Yeah.
Tire and steel are going to be heavier.
Yes,
but
they are.
those have different. You know, you have to try the frames that you like. You have to ride the frame you like, and you know, don't feel like you're missing out on the best frame for your use or the best frame out there, just because it happens to have been made of the materials that nobody really favors in bikes. I mean, this is the only mag frame you can get now. But there are loads of aluminum bikes out there, and aluminum is a really good material to make a bicycle frame out of.
Yeah. Cannondale built an empire on aluminum frames.
Yeah, and yes, there is eventually there is a fatigue life limit on any of the metallics that carbon doesn't have. You will eventually wear out and crack any bike that isn't carbon.
Yeah.
If I should wear out, judging by the number of
Yeah,
bikes,
but how many hundreds of thousands of cycles?
well, I was going to say that I can readily find on Craigslist aluminum bikes that are 25 years old and not cracked, and so if you buy a new aluminum bike at the age of 40, and it cracks when you're 65, do you know what you do? That's right, you go out there and you buy another bicycle.
You buy another bike. I mean, just yeah.
So this is
forever. Forever doesn't mean forever. It just means
until
I want something else.
Until it'll last longer than it'll last longer than you want it to.
Yeah.
That's what forever means in the bicycle
true.
world.
That's true. So if we go back to this frame real quick, could you tell me like maybe tube not diameters, but tube thicknesses, what they can do differently with mag that maybe you can't do with steel or tie? Like,
absolutely.
Is there better?
So you're limited on how thin you can make a tube before it stops being a tube locally, and you get and any load causes local buckling or crippling. That's why you don't want to clamp the down tube of a Cannondale if you can avoid it. And that ratio is fairly constant across those four metals. And so to get the best bending stiffness, you end up wanting to have the thickest, largest diameter tubes you can get. And the increasing density as you go from mag to aluminum to tie to steel means that the frame tubes get smaller and smaller with each material. And so if you want a stiff, big tube ride, well, that points you towards the lighter metals, towards aluminum, and then towards magnesium. And since I'm a sprinter,
and you like that,
that points me that way.
That hurts me, so I try not to do too much of that. So if you ever invite me to one of your group rides, I'll just see you go up the road, because I'm not. I'll try to chase, but
you'll catch me near the end of the ride after I burn the entire tank of fuel.
So speaking of, so if you were to build a mag bike, let's say like this, out of round tubes, because I can see that these are all shaped, would that reduce its stiffness?
So the tubes in the back are round because that's stiffness driven for a beam that's tension and compression.
Okay.
But the forming does improve the bending stiffness of it because it gets the material closer to the sides when you're in bending, and closer to the top and bottom when you're in bending this way.
Yeah.
So
it's just pressing it up against whatever that form.
Correct. It presses up against that form,
and it just
yeah.
I wouldn't say thickens it, but it just makes it.
Well, so you get
compresses it.
It's not that the properties of the metal itself don't change. What you do is you get a better beam. A steel tube is an equally bad beam in any direction if you put a bending load in the middle of it.
Yeah.
And so it will react the same. It's just that that's probably the least efficient method of reacting that load in any closed section. What you'll put a square tube or a rectangular tube in a design because that gets the material further away from the middle of the section shape, which increases the ability of it to resist that bending load.
So this whole thing that Cervello used to talk about, the squoval tubes that were square but oval, this was how they were trying to get away from the round tube because, as you said, the further you can move away from the center, the stiffer that. Okay.
Yep.
Yeah,
so
yeah.
You try to make.
And then
things
they were trying to lop off the corners to make it arrow, so that it wouldn't be square.
Yep.
But square is stiffer. Yeah.
Yep. Square is stiffer. Well, close to square is stiffer. You probably want to put. If you go to a dead sharp edge, you get lots of cracking when you try to weld it.
That'd be yeah.
But yeah, and obviously you don't want to slide off your saddle and flick yourself down on on a tube that is actually sharp edged and square, especially for the men out there.
Yeah.
Yeah.
Well, women too. I mean,
that's true.
That's true.
Yeah.
We all have our
yeah. You don't want to crash.
Our sensitive.
You don't want to crash there. We can probably edit that portion out.
No, it's fine. It's fine.
All right.
But
yeah.
But yeah.
So
and I just noticed, and I don't know why I didn't mention it earlier. What material is the bar made out of? Is it carbon or
I
is
have
it?
no idea what this bar is made of. It's non-metallic.
Yeah.
I tried to take these ends out.
Yeah.
And then I can't actually see any carbon in them. This may just be a fiberglass.
Okay. All right.
But I don't know what it is. It's VAAST hasn't told me. I know the fork is carbon.
Yeah. Because I was curious. I mean, it's all branded. It's all part of their own thing. It looks like. So I was just curious what material it was made out of. Yeah.
Yeah.
And just for some folks that might be curious, what did you what do you have as a weight on this bike? Because I know some folks ask.
Well, we can go and verify it, but I think this bicycle weighs around 18 pounds.
18. Okay. Yeah, we should probably just take it into the scales of truth. But okay. So, Charles, thank you so much for taking the time to show us your bike, to teach us about metals and composites and how to design a bike, and or how bikes are designed, I should say.
Yep.
So, it is always interesting because some folks just ride a bike, but you actually know what's going on with the tubes and the shapes and the materials and way more. It's funny when you also test rode my Road Logic, my Ritchie, you were like, wow, okay, that steel bike tracks the way it's supposed to. And then you rode the Specialized Roubaix, and because you rented it one day for whatever reason, and you were like, no, that bike just is doing two different things, the front end and the back end, right?
Yeah, that's I didn't want to single out a single manufacturer
I'm okay
there,
with it.
but it's quite possible to design a bicycle out of any material you like that is inadequately stiff in a couple of different planes.
Yeah.
That is a bicycle that you can definitely say has inadequate lateral stiffness.
Yeah.
That's not a slam at their current products. I have not ridden
I'm pretty sure
one,
they've worked around that since.
That specific bicycle, that had a hinge in the middle.
Yeah. All right. Well, thank you so much, Charles. I really do appreciate your time, and I do appreciate your business, your repeat business. So for everyone else, if you found this discussion engaging, Please drop a comment down below, and please like and subscribe, and we'll see you up the road.